for this problem, what we want to do is we want to figure out how to maximize the volume of an open box. So it says an open box of maximal volume is to be made from a square piece of material which has 24 inches on each side, and they want to cut equal squares off the corners and turn up the sides. So what they want to do is they want to take a sheet and they want to cut little squares from the corners and then fold it up and make a box. So what we've got is to cut off these. If we shaved off these corners here, and then kind of folded it up, you'd end up with a box. So how do we figure this out? Okay, well, the first thing we have to do is to figure out what they gave us. They gave us that it's 24 inches per side. It's a square, so I kind of already drew that. And they cut squares from the corners, kind of already drew that. And they want the volume, so they gave us what they want. What do they need? They need volume. Well, we've got some sort of box. So volume in general is length times width times height. Okay. Well, if we come over here, we see that we cut away, let's call it X. So if this whole side was 24, this new piece is 24 minus X. And similarly, this new piece is 24, I'm sorry, not X, minus 2X. Right? Because I cut X on both sides, because this whole area is 24. So then, if I were to draw that as a box, that tells me that if I fold this side up, it has that width X, or that height X. So 24 minus 2X, 2X and X. So that tells me my length, width, and height are 24 minus 2X, 24 minus 2X, and X. Okay? Now I can factor out 2 from this one and a 2 from that one, so I can get a 4. Let's pull the X to the front, and that will become 12 minus X squared. And that is one way to do that. Might be more helpful to write that out as 4X times X squared minus 24X plus 144. Which would be 4x cubed minus 96x squared plus 576x. I don't know, whichever way is beneficial to you. So length, width, and height are here. Now we have to figure out how to maximize this thing. Well, if I've now have a volume in terms of one variable. So if it's in terms of one variable, I can take the first derivative. The first derivative is 12x squared minus 192x plus 576, which then I can pull out a 12, x squared minus 16x plus 48. So x squared minus 16x plus 48. Well, that, as far as I can tell, does that factor? Is that 12x minus 12, x minus 4. Okay, x minus 12, x minus 4. So that gives me critical points of 4 and 12, because if x is 4, then this derivative is 0. If x is 12, this derivative is also 0. For good measure, let's get the second derivative. We get 24x minus 192, which is 24 times x minus 8. Okay. So we can take these critical points and we can plug them in, but let's think about a domain here. Well, the first thing I know is that the domain has to be x can't be any less than 0, right? Because otherwise you're not cutting anything at all. But x really can't be any more than 12, because if you cut more than 12 off of this side, you can't cut more than 12 off of that side. So that tells me that x is somewhere between 0 and 12. Now, what's also interesting is 12 was a critical point. It kind of makes sense. But if you plugged in 12 to this, by the way, if you plug in 12, think about this. If you have 12 here, and you cut 12 and 12 off of each side, then you don't even really have any volume. You just have you have a piece of paper that if you did 12 by 12, you would end up cutting those 4 rectangles, and you wouldn't really have a box. So you would, and that's bare. If you put that out here, if you put 12 in here, v double prime of 12 is positive, v double prime of 4 is negative, which is a max, or a min and a max respectively. So second derivative test tells us that this is our maximum. If we try to take this and plug this into the original formula, so we take v of 4, we get 256 minus, let's see, that's going to be 6 times 256 plus, let's see, because that's 6 times 96, so that's like, trying to figure out how that works. If I do 256, if x is 4, that's going to be 20, anyway, let's think about this. 256 divided by 4 is 64. 64 goes into this 9 times, so that's going to be 256. So you end up with 4 times 256, so you end up with 1024. These are the tricks you have to do when you don't have a calculator, you didn't do it beforehand, and you really don't feel like doing it all by hand, even though that probably would have been faster here. Sometimes it's neat to be a little bit clever. So v of 4 is 1024, but if I plug in my endpoints for my domain, if I plug in 0 to this, I get the same thing as if I plugged in 12, right? Because if I plug in 12, that's also 0. So what that tells me is a cut of 4 inches. So I have 4, 4, and 4, or rather 8, 8, and 8 because of that. So if I cut 4 off of each side, then I end up with something that's actually more like a cube. What you find a lot of times is maximal volumes happen with squares, cubes, where the sides end up being equal. That's a very, very common thing.